Assalamualaikum warahmatullahi taala wabarakatuh dan selamat sejahtera. Okay, today our objective is to understand the force extension graph so until the wire breaks. So that is our goal today, to understand the force extension graph until the wire breaks. Okay, so we focus on this simple experiment. So we have the wire with the L0. L0 is the original length, initial length of the wire. Then we apply the force F1 to the wire, and then what happened to the wire? The wire start to extend. So in this case, E1. Then we plot for the graph F1, and then E1 is the extension of the wire. So we have the first dot here, the first mark here, and then after that we remove the F1. Then what happened to the wire? The wire go back to the initial length L0. Then we continue with the F2, the apply force F2, and then what happened to the wire? So the wire extend so as a E2, and then we plot the graph F2, and then we have the E2, the extension is the E2, and then we remove the F2. Then what happened to the wire? So the wire go back to the initial length L0. Then we continue, we apply the F3, then we have the new extension E3. So we continue with the F4, so we have the extension E4. Then we apply the F5, apply force F5, then we have the new extension E5. So in this case, from the F1 until the F5, so we plot the graph, and then we have the linear graph. So in this case, what we can say is the extension is directly proportional to the applied force. So that's mean when we increases the applied force, that's mean the extension of the wire also increases. Okay, so this one, so we have the F is directly proportional to the E, and then we have change from the directly proportional to the equal, so we have to put the constant K and E here, extension. So this one is the equation of the Hooke's law. So that's mean from 0 to the point A, so this one is obey the Hooke's law. Still obey the Hooke's law from here to here, F5. So this experiment, the wire still obey the Hooke's law. And then we continue with the F6. When we continue the F6, then what happened? So the wire still to extend. So in this case, we label as a E6. But what we can see here is not obey the Hooke's law, but the wire still elastic. That means for the F6, we put the apply force F6, the wire still extend, but in this case, it's not obey the Hooke's law, but the wire still return to its original length L0 when the apply force, in this case, if the F6 is removed. Okay, so in this case, we have the point L. L is a elastic limit. So in this case, what we can see here, the wire still go back to the initial length L0, but did not obey the Hooke's law. That means that it's not directly proportional to the extension. Okay. So we continue. So we still increase the force now to the F7. And then what happened? So what happened to the wire? The wire start the plastic deformation. So that means the wire starts to become a plastic. Okay. So that means we have the new point here is the yield point. So yield point actually is the point where the wire start to be a plastic. And then we continue for the F8 apply force, and then what happened here is the produce what happened, the thin non-uniformly, that means the wire now form a neck. So form the neck. So and then we apply the F9. So what happened, the wire start to break. So between the F7, F8 until the F9 is all in the plastic deformation. So that means atomic plane slip over one another due to the movement between the plane. So in this case, from the yield point B, C and D form a neck, C form a neck, and D the wire breaks. So in this case, what we call here in the plastic deformation. Plastic deformation happen, why? Because the atomic planes, they slip over one another through the movement between the planes. So in this case, we try to understand the graph of the F, again the extension, and then actually what happened inside the wire. Why the wire form the plastic deformation? Because the slip, because the atomic plane, they slip over one another. So the yield point, they form the neck, and then the last, the wire break. For that, thank you.